Hi class, welcome to lesson 14. As I said before, we're continuing microeconomics. Last class we covered over consumer choice and we kind of wrapped up that topic, and this class we're actually going to move on to other topics in microeconomics. But before I start moving on, as usual, let's talk about the answer to the homework question. Homework question last time in lesson 13 was tell me the 5 main points behind consumer choice. So that was the question. The 5 points are consumer rationale, that's 1. 2 are consumer preferences. They rank their preferences, right, in order of their utility and what they want, right? 3 is the fact that consumers understand diminishing marginal utilities. I'll cover that a little bit more in detail. 4 is the fact that there are other constraints like prices and income that affect consumer choice. And the 5th one finally was that the utility maximization principle. If you had a certain income and you were to choose to buy goods X and Y, it's going to be based on the fact that the consumer will buy those goods, and how much of it will be bought will be based on the fact that how much utility is being maximized, and is this utility being maximized. So with that being said, let's start with that topic, right? So let's talk about number 5. That's going to talk about utility maximization, which is also going to include diminishing marginal utility. So this is the 5th one. We're continuing consumer choice. And currently we're talking about utility maximization, right? Utility maximization. Maximization. Utility maximization with, I believe this is an I, I'm sorry about the spelling, okay? But anyways, utility maximization, and this is most importantly, it's with a constraint. Okay, and the constraint, generally speaking, is the income, okay? So to kind of talk about this more in detail, I decided to let's do a classroom example of what we consider where we'll use utility maximization. So in a sample question, right, they generally will give you a table, okay? In the table, we have 2 products, okay? Products X and Y, okay? Does that make sense? All right. So in this new table, let's call it table 1. Okay, and this is an example, okay? This is an example, all right? You're going to have, first, you're going to have units of X, okay? And that's going to be one particular section, all right? Next is going to be the marginal utility, MU, derived by X, okay? Next is going to be units of Y. And as you can probably guess, the next section is going to be marginal utility derived from Y, right? MU derived from Y. There's one piece of other information before I start filling these tables out. There's one other thing that's pretty important, and that's the prices of X and Y. What are X and Y worth? And in this particular example, price of X is $8. Okay, for 1 unit of X, it costs $8. For 1 unit of Y, I believe this example says that it is worth about $4. Okay, so let me go ahead and start filling these. Okay, so let's start with the units of X. For 1 unit of X, it states that you get 56 MU of X, as in marginal utility. Utils are the concept, right? So the way, when you say marginal utility, what is this unit? Okay, 56. The technical word for this is actually utils, okay? UTILS. Okay, that's the units of utility, right? So 56 utils, right? It's the satisfaction. We said we were trying to quantify this. And I'm going to go ahead and start to fill out this table, okay? So for 2, I believe it's 48, 3, it is 32. For 4, it is 24. 5, it's 20, I believe. Yeah, 5, it's 20. Okay. And then over here, units of 1, same thing, right? 1, 2, 3, 4, 5 for units of y. And then the numbers are 32, 28. This is just an example. 24, 20, and 12. Okay. One of the most important concepts that we're going to talk about in utility maximization is the following. We said that given a particular income, right, a particular constraint, right, and let's set an example. In this example, let's say that this person's income is set at $52, okay? Income, which is our constraint, is at $52. One of the most important ideas to understand in utility maximization is the fact that the marginal utility, okay guys, the marginal utility of the first product, right, product X, okay, over the price of X, okay, should be equivalent to the marginal utility of Y over the price of Y. And I'll tell you why that's important, okay? And I'll box this to tell you guys how important this is. Okay? This is very important because this says the following. If I, as a person, as a consumer, I'm trying to decide what to buy based on a certain income, right? In our case, it was $52. Based on this $52, what it's saying is that if I'm buying X and Y, let's say this is X's milk, Y's bread, okay? What it basically says is that the amount of milk and bread that I buy, okay, the amount of milk and bread that I buy, the utility that I get per dollar, okay, the marginal utility that I get per dollar for milk should be equivalent to the marginal utility of bread that I get per dollar, okay? I'm going to say that one more time. The utility of one product per dollar should be equivalent to the utility of the other product per dollar, okay? So how do we say that in this example? Okay, the way we use it is the fact that we don't know what MUX, MUX is variable for each product, but the price does not change for X or Y, correct? So we say that MUX, right, over PX, MUX changes for every single unit, right? PX, we already said, was $8, right? So the cost of X is $8, okay? Well, we'll go over here, say MUY. Well, we don't know what MUY is. It's kind of, different for each single unit. So we'll leave that alone. Okay, we'll say this is MUY over, but the price stays constant at $4, right? So we'll say this is $4, okay? That being said, let's try to make sense of this formula, and we'll try to rearrange it. The way I'm going to do that is I'm going to multiply the 4 on each side, right? So I get 4, right, times, right, dot is times, okay, MUX over 8, right, this is $8, this is $4, is equivalent to MUY, marginal utility of Y. Now, one other thing I'm going to do is I'm going to multiply each side with 1 over MUX, okay? So I'm going to multiply each side with 1 over MUX. If I multiply each side with 1 over MUX, right, 1 over MUX, the MUX on this side cancels out, right? Marginal utility of X cancels out. On this side, if I multiply by 1 over MUX, it turns it into MUY over MUX, right? So I'm going to create a new example. It says 4 over 8, right? 4 over 8 is equal to MUY, marginal utility of Y, for marginal utility of X, right? That is 1/2, correct? So I'm going to simplify this. This is 1 over 2, right? Or the other way of saying it is 0.5, right? So this is basically saying marginal utility of Y, right, over the marginal utility of x over here, right? It's marginal utility of x is equivalent to 0.5, okay? So what we have to simply do is, looking at these set of units, right? Looking at this table right here, we got to see where MUY, okay, this row over MUX equals to 0.5. Now the other tricky part that we have is the fact that the amount of money that you spend, okay, whatever units of x times the price of x, okay, so units of x times the price of x plus the units of y times the price of y should be equivalent to $52, you know, because that's our budget, okay, and this is how we maximize it. So just looking over it, right, I have MUY over here, okay, I have MUX over there, and do you guys just see off the bat, you know, do you guys see anyone that makes 0.5, right? So basically I'm saying is this row over this row should equal 0.5. Well, you know, by looking at it, you know, 32 over 56, not 0.5, 28, 42, but you guys kind of can guess, right? So if you look at 12, well, is there something that, you know, is twice MUX, right? Because if you look at this, right, if this is 1 over 2, okay, what this is basically saying, I'm just rearranging the formulas, okay, it basically is saying that MUY, right, times 2, and the dot means times, okay, or you can say x, okay, I don't want to use x because the variable is x, so I'm going to use the dot for multiplication, okay, so it's saying 2 times MUY, right, 2 times MUY is equivalent to MUX, okay, something 2 times the marginal utility of y is equal to MUX. So if I take this row and I multiply it by 2, okay, if I take this row and multiply by 2, I should find a number over here as MUX, okay? So let's see, is there anything that you can find? The one thing, I mean, there are two things I can find. There's 28 times 2, which is 56, okay? And then I have 12 times 2, which is 24, okay? Now, that's the, you know, those are the two things. I don't see 40, I don't see 64. You know, I'm just multiplying these by 2. So I'm just saying. So the two ones that I get that kind of match this formula, okay, is I believe combination of 28, which is 2 units of y, right, with 1 unit of x, okay? And I'm going to match these out like this. Okay? The other one I do see also is 24 times 2 is 48, right? So 3 units of y with 2 units of 48. Okay? I see that as a match as well. The last one that I see is 5 units of y with 4 units of 24. Or of x, rather. Okay? So I see 3 possible combinations. Okay? So I'm going to go ahead and erase this side of the board so we can go ahead and solve what is the best combination. Now remember, what I told you guys before is the fact that what we're looking for here, okay, the first part is seeing the, is matching this, right? So this is number 1. You got to make sure this clicks, okay? So we found 3 possible combinations, right? We said, well, we can have, so I'm just going to say, right, with 0.5, right, when it equals to MUY over MUX, right? We found 3 combinations, okay? So this is X, this is Y, right? We said we can have 1 unit of X, right, which is 56, and then 2 units of Y, okay? Or we could have 2 units of X, okay, with 3 units of Y. Or we said that we can have 4 units of x with 5 units of y. Okay? So these are the 3 combinations that we have. All right, fine, that's fine. I mean, it clicks this, right? It says 0.5 is equal to MUY or MUX, right? 2 or 1, right? I mean, 28 over 56.5, all that stuff. That's fine. Well, the other part that we got to really look at is looking at the income, right? We cannot spend more than $52, okay? So my question is, if I multiply these units out, how much is going to be my cost? Okay? Well, let's look at it. And let's also, one more thing I really want to look at is my total marginal utility. So this is going to be, this example is going to take some time because it's our first example, and you guys, once you get the hang of it, it's going to take, it's going to be way faster. But let's take the first combination, okay, of 1 and 2. I'm going to take this combination of 1 unit of x and 2 units of y. What's the total cost? So if I take 1 unit of x, it's going to cost me $8, right? It's going to be my cost, okay? Okay? It's going to be $8, right, for 1 unit of x, okay? Plus, this is the first combination, okay? $8, and then I wanted 2 units of y. That's about $8 as well, right? Because 2 times 4 is 8. Get this? 2 units of 4, and 2 units of y, and each unit is $4. That's $8. So total cost is 16. Okay? So that's 16 over here. All right? So then let's take the second combination, right? We said 2 units of x, right? 2 times $8. Okay? Plus, this is number 2, right? 2 times $8 plus, how many units of y, guys? 3 units of y times 4, okay? So 3 times $4. That gives me 12 plus 16, right? $28. Okay? 28. I'm still within my budget, okay? Now, let's take the third combination, which is 4 units of x, right? 4 times 8, 32, plus 5 times 4, which is 20. And everyone see how I got that? Okay, I'm using 4 units of x times the price of $8, 5 units of y times 4, okay? So this is 20 plus 32, and this is exactly 52. Okay, so the first part is we're still in the budget. Now, one of the goals of all of this is, when we say utility maximization, it's a two-front thing. Obviously, okay, we have to make sure that marginal utility is maximized, right? Or rather, your marginal utility is maximized. That's one part. The second part, a hint is to make sure that you're using most of your budget, right? What I mean by that is, I have not calculated the marginal utility, the total marginal utility yet. But when I discuss these things and when I've calculated the costs, right, and it's 16, 28, and 52, chances are this is the best combination. I'm not calculating the marginal utility yet. But what do I mean by that? Well, we're using all of our income. If we're using only $16, right? There's a whole bunch of income that we're not using, right? In the case of 28, right? There's another income that we're letting go. So in order to be maximizing, when we're utility maximizing, right? We cannot waste resources, okay? And we have to make sure we take full advantage of it. So, all right, so we've calculated the budgets and we're within budget, and this one looks the most promising because we have used the most amount of money here, okay? And it's not necessarily true because the best test, okay, is the next part we're going to do. This is the most important, and it's the marginal utility, okay? Marginal utility, the total marginal utility that we're going to get from this particular combination, these combinations, the biggest marginal utility is going to win because at the end of the day, it is a utility maximization concept, okay? It's not income maximization, it's utility maximization with the given constraint, which is your income, okay? So that being said, we have our costs. Now let's look at the marginal utility, which is the most important thing because remember, this is utility maximization. So what we're trying to do is we're saying, okay, what is the amount of marginal utility we're getting, right? I'm going to create a column, right? TMU, and okay, this is just total marginal utility, right? So TMU, in my opinion, is going to TMU, total marginal utility, okay, is the marginal utility that I get from X, okay, plus the marginal utility that I get from Y, okay? So this is TMU, and this is the formula, this is the column over here. All right, so let's do the first combination, okay? So the first combination is I have 1 unit of X, okay, which gives me 56 utils, okay? 56 utils, that's marginal. If you look over here, first unit gives me 56 marginal, if you look at the MUX column, it's 56 utils, okay? So, okay, so I get 1 unit and I get 56. Okay, that's cool. All right, how much do I get? I'm using 2 units of y. For 2 units of y, I get 28 utility. Everyone see that? 2 units of y and get 28 utils. Okay. Well, if I add this up, right, that gives me the total marginal utility for the first combination that I have here. Okay? So, if you want to do this, you can do this by hand. You can do this by, whatever you'd like. Okay? But basically, the point is to calculate, what is going to be our total marginal utility. Okay? So total marginal utility is 56 plus 30 is, this is just in my head, okay, is going to be 86, but it's going to be 84, okay? This is 84, all right? So 84. All right. Our second combination says we're using 2 units of x and 3 units of y. For 2 units of x, looking over at the chart over here, okay, everyone see this? It's 48 MUX, okay? So marginal utility, I'm getting 48 utils, okay? I add that with 3 units of y. For 3 units, I'm getting 24, right? And as everyone hopefully can see, it's going to be a little higher at 72, okay? I'm getting total marginal utility of 72, okay? So this is not actually higher than the first combination, okay? So the first combination is actually better than the second combination, right? All right, so that looks cool. Okay, so we said this is 72, this is 84. Let's look at the last one, third. Okay, I'm using 4 units, which gives me 24, right? And 12 units, which gives me 36. Okay, now the most important thing is, as you can see, actually this column is slightly incorrect. Okay, now let me tell you why I did this. It's very easy for someone to look at this and say, well, you know what, going over here to this chart, someone can go, well, for 4 units, I'm getting 24, that's my marginal utility, and I'm done there. The way this works is that it's more of the fact that we're trying to maximize the utility, but this is actually per unit, okay? So in order to accurately calculate, okay, the total marginal utility, we actually multiply the units, okay? The reason why it works here in this case of x is because we actually take 1 unit of x and multiply by 56, and we get 56 as a total marginal utility. But for 2 units of x, we actually have to multiply per unit because MUX is always per unit, okay? Does everyone make sense? It's always per unit, okay? So we have to add all the ones that we get before. Okay, so walking over back here, let's recalculate our marginal utility. So for the first one that we get, right, MUX, we get 56. That is correct, first unit. And we said we actually use, so we're going to recalculate total marginal utility again, okay? I wanted all of you to understand that it's not simply just looking over in the chart and calculating this, okay? It's more of the fact that you have to look at the entire parts, okay? What do I mean by this? All right, so let's look at the first combination again, okay? Let's revisit that. Part 1 says 1 unit of x, 2 units of y. The first part is correct. When you want to see marginal utility of x, you say, well, 1, 56. Okay, well, I have 56. That's perfect. Now here's the tricky part, okay? When I have 2 units of y, I have to add the marginal utility that I get from the first one and the second one, okay? So it's plus 32 plus 28. Everybody make sense? The next part is for the second combination, 2 units of x, so I have to include 56 and 48, okay, because that's how it is for here. So we add both of these. Then we move on and we say, well, 3 units of y, right? So we have to add all of these down, okay? So it's 32, 28, and 24. Okay? The last combination for 4 units of x, when we go over here to this chart, we have to add all of these for the total marginal utility, right? Because for the 4 units of marginal utility, you're getting the first unit, the second unit, the third unit, and the fourth unit. So you have to add the marginal utility of all of these, okay? So I add 56, 48, 32, and 24. And for 5 units of y, I have to add all of these down, okay? So it's 32, 28, 24, 20, and 12. Okay, so this is the first combination, second combination, and third combination. As everyone can see, the total marginal utility that you get from the third is going to be the greatest, okay? Which is why the third combination is the best combination. It's maximizing utility, okay? Maximizing utility. Now you can ask me, hey, what if I had number 6 here, hypothetically, 7 here, right? What if I just add up all of these? Isn't that going to be always the best? Well, here's the good thing, right? Of course, if I have 6 and 7 units, I'm going to get the greatest amount of utility, okay? Greatest amount of utility. But the thing is, one has to realize is, by the way, guys, this is total utility, okay? I'm sorry if I said total margin utility. This is actually total utility, okay? Total utility. I don't mean total margin utility. This is actually total utility, okay? It's actually total utility. One of the things I want to tell you guys is, when I add all of these up, okay, and when I add all of these marginal utilities up, I'm getting the total utility. The question is, most people ask, well, if I have 6 units, 7 units, I'm going to get greater and greater amounts, so it's always going to be the best. The trick is that you're going to be past your income, okay? Never can you be past your income. You cannot go past your income. The reason why it says utility maximization with constraint is you cannot go past the income, okay? You cannot. So if I have 6 and 7 units, chances are that it's going to be greater than this income of $52. You cannot afford something that you make more than, okay? So if I make $52 and it costs 6th and 7th unit costs $74, it's not possible. We can't take a loan, we can't do that. So make sure you stick to this income. First part is you calculate this, okay? MUX over PX equals MUX over PY. You get the ratio, okay? In our case, it was 0.5. Then you make sure that you're not going over the income, right? So you calculate the total cost, okay? This is the second part. You make sure that you're not over your income. So you have to calculate the cost, okay? Calculate the cost. Third part is make sure you're maximizing utility. So for the combinations that you have, 1 and 2, you add the utility and you get the total utility, okay? You get the total utility, all right? So that being said, to wrap this up, I'm going to go ahead and erase this, okay? And tell you guys steps 1, 2, and 3 again, okay? So that being said, for a utility maximization problem that gives you a constraint, I'm going to say this one more time. For a utility maximization problem that gives you a constraint, 3 things to do. 1, calculate MUX over PX and MUY over PY ratio, okay? This is the first part. You got to calculate the ratio. MUX over PX, so marginal utility of a product X or a PX, could be anything. Could be JK, whatever you want. But you have to calculate this ratio. Second part is to understand what the income is, right? Your income is some number, okay? This is some number, right? And then there are a couple things you have to do. One is, using this combination, the first one, you got to figure out what are the combinations, okay? What are the combinations? I'm going to write combos as combinations. So what are the combinations you have to understand, okay? Based on these combinations and based on the income, okay, you have to figure out the cost of these combinations, okay? The third part, after seeing the cost and making sure you're within the income, third part is to calculate total utility, okay? Okay? And whichever one with the highest utility, okay, highest utility, right, is the best combination. So that will be your answer. The combination with the highest utility and is within your income will be the utility maximization bundle that this person wants. A bundle is a selection, right? So a bundle would be a combination of goods. Okay, I'm going to say that one more time. A bundle is a combination of goods. Okay, so if a bundle would be 1 unit of X and 2 units of Y. A bundle would be 4 units of X and 5 units of Y. It's just a bundle. A bundle is a combination of goods. So a bundle, right, with the highest utility, total utility, is going to be the amount that the person's going to choose if the person's rational. Okay, so, consumer choice, we've covered this with this lesson over here. For utility maximization, remember these 3 points that I've told you guys to solve a problem. In the next problem, we're going to try to solve again another problem just like this one. Hopefully we're going to go a little faster, right? But basically, I will leave you guys with these 3 main points and a homework question for the next lesson. My homework question is the following. For consumer choice, when you're trying to maximizing utility, right? What are the steps that you have to take in order to figure out the maximum utility bundle? Okay? So I'm going to say it one more time. What are the 3 steps that you have to take to maximize the utility bundle? All right? So for utility maximization problem, what are the 3 steps you're supposed to take? I'll come back with the answers and I'll try to give you guys, I'll try to go through a sample problem and get in the next one so that you guys can understand this. Okay? So hopefully I'll see you guys in the next lesson. Thank you so much for joining me.